Zn is the notation for set of all residue classes module n, and we seen in last lecture that there are precisely or exactly n residue classes module n, and what are that? 0 bar, 1 bar, 2 bar, 3 bar, up to n minus 1 bar. These are only the distinct residue class module n, and the set of all these distinct residue class module n is denoted by Zn. So what is Zn? Is 0 bar, 1 bar, 2 bar, up to n minus 1 bar, and this is the notation for the set of all distinct residue class module n. And therefore what is Z5? So Z5 is 0 bar, 1 bar, 2 bar, 3 bar, 4 bar, because under module 5, if n is 5, then we have the only 5 distinct residue classes: 0 bar, 1 bar, 2 bar, 3 bar, and 4 bar. And this set is denoted by Z5. So in this fashion, Z8 is what? 0 bar, 1 bar, 2 bar, up to 7 bar. Z3 is what? 0 bar, 1 bar, 2 bar. Z4 is what? 0 bar, 1 bar, 2 bar, 3 bar. That is, Z4 contains 4 distinct residue classes. What are that? 0 bar, 1 bar, 2 bar, up to 3 bar. In this fashion, Z7 is what? 0 bar to 6 bar. So these are the set of all distinct residue classes module n, if n is 1, 2, 3, 4, 5. Okay. So we can define the addition and multiplication in Zn. So the addition, this I bar and J bar are element of Zn. Then the addition is denoted by I bar plus J bar, and is I plus J bar. And the multiplication defined by this, denoted by this I bar dot J bar, that is right dot. Then or the empty space I into J, I bar into J bar is I into J bar. So these are very simple definitions of addition and multiplication in Zn. And these notations for addition and multiplication in Zn also denoted by that is plus sign in bottom n. That is, this is the notation for addition module n, and this is the multiplication module n. That is, we simply denoted simple addition sign and simple multiplication sign, or addition sign suffix n, multiplication sign suffix n. So these are the notations. Another notations to denote the addition and multiplication in Zn. So in new notations, a bar plus addition module n plus b bar, that is a bar plus b bar module n is what? A plus b bar. The definitions are same, only notations are changed. So notation for multiplication module n is this: a bar into b bar is what? A into b bar. So these are the definitions of addition and multiplication in Zn, and notations for their notations. That is simple addition and simple multiplication notation, or addition suffix n, multiplication suffix n. These are the notations for addition module n and multiplication module n. So first example is what? In Z6, what is 3 bar plus 5 bar? That is right, plus sign, just call plus sign, this plus sign, or plus suffix n, or plus suffix 6, because n is 6. So plus suffix 6 or plus suffix n. So this is the definition of this is the notation for addition. So 3 bar plus 5 bar is what? 3 plus 5 bar. By using this notation, 3 plus 5 bar, that is 3 plus 5 is 8 bar. And what is 8 bar in Z6? Is 2 bar. That is, if you divide 8 by 6, 8 by 6, then what is the remainder? 2 is the remainder. So is 2 bar. 5 into 3 bar is what? Is 5 into 3 bar. That is 15 bar. And what is 15 bar in Z6? Divide 15 by 6. Then what is the remainder? Remainder is 1. That is 6 to the 12. So this 15 bar is 3 bar, actually, not is 1 bar. This is answer. This answer is wrong. Right here, 3 bar. Because 15 bar in Z6 is what? If you divide 15 by 6, then 2 is the quotient and 3 is the remainder. So right here, 3 bar. Similarly, in Z7, what is 3 bar plus 4 bar? Is 3 plus 4 bar. That is 7 bar. And what is 7 bar in Z7? Is 0 bar. Because if you divide 7 by 7, then remainder is 0. Quotient is 1. In 0 in Z7, 0 bar is 7 bar is 0 bar. Okay. And then 3 bar into 4 bar is what? 3 into 4 bar. That is 12 bar. And what is 12 bar in Z7? If you divide 12 by 7, then quotient is 1 and 5 is the remainder. So 5 bar. 12 bar is 5 bar in Z7. So this is the table for addition and multiplication in Z7. It is called composition table for addition and multiplication in Z7. So the question on this topic is what? Draw or write the composition tables for addition and multiplication in Z6 or Z7 or Z8. So this is the addition table for Z7, and this is the multiplication table, composition table for multiplication in Z7. So Z7 is what? Contains 7 elements. What are that? 0 bar, 1 bar, 2 bar, 3 bar, 4 bar, 5 bar, and 6 bar. And then what is the addition table? Write here plus sign, suffix 7, or just write plus sign, because this is the notation for addition module 7. That is just write plus sign or plus at the bottom 7. And then write the entries of Z7, that is 0 bar, 1 bar, 2 bar, 3 bar, 6 bar in this first row. And in first column also write the elements of Z7, that is 0 bar, 1 bar, 2 bar, 3 bar. So the first row and first column are the elements of Z7. So 0 bar, 1 bar, 2 bar up to 6 bar, 0 bar, 1 bar, 2 bar up to 6 bar. So similarly in the multiplication table, the first row contains the elements of Z7, and this first row, first column and first row contains the all elements of Z7. So the first row and first column in multiplication and addition tables are just the elements of Z7, same. That is, and then the entries. So 0 plus 0 is 0. So 0 plus 1 is 1. 0 plus 2 is 2. 0 plus 3 is 3. 0 plus 4 is 4. Then 0 plus 5 is 5. 0 plus 6 is 6. Then 1 plus 0 at this place, 1. 1 plus 1 bar is what? It's 2 bar. Then 1 bar plus 2 bar is 3 bar. Then 1 plus 3 bar is 4 bar. So 1 plus 4 bar is 5 bar. Then 1 plus 1 bar plus 5 bar is 6 bar. Then 1 bar plus 6 bar is 7 bar. But 7 bar is what? Is 0 bar in Z7. Then 2 bar plus 0 bar is 2 bar. 2 bar plus 3 bar, 1 bar is 3 bar. 2 bar plus 2 bar, 2 bar plus 3 bar, 2 bar plus 4 bar is 6 bar. Then 2 bar plus 5 bar is 7 bar, that is 0 bar. 2 bar plus 6 bar is 1 bar, because 2 plus 6 is 8, and 8 bar is 1 bar in Z7. That is, if you divide 8 by 7, then remainder is what? Remainder is 1. Similarly, all the entries, 3 bar plus 4 bar, 3 bar plus 4 bar is what? Here is 3 bar plus 4 bar is 7 bar, that is 0 bar. 3 bar plus 5 bar is 1 bar. What is 3 plus 5 is 8, and 8 is 1 bar. Then 3 plus 6 is 9 bar. And what is 9 bar in Z7? If you divide 9 by 7, then 2 is the remainder. Okay. Similarly, 5 plus 6 is what? Is 11 bar. 11 bar. And what is 11 bar? If you divide 11 by 7, then 4 is the remainder. So 4 bar. Similarly, 6 bar plus suppose 3 bar is 9 bar. 9 bar is 2 bar. Because if you divide 9 by 7, then 2 is the remainder. 6 plus 6 is 12. And what is 12 bar? If you divide 12 by 7, then 5 is the remainder. Similarly, the composition table for multiplication is this. 0 into 0 bar is 0 bar, 0 bar into 1 bar, 0 bar into 2 bar, 3 bar, 4 bar, all entries are 0. Then 1 bar into 0 bar is 0 bar, 1 bar into 1 bar is 1 bar, 1 bar into 2 bar is 2 bar, 1 bar into 3 bar is 3 bar. Similarly, all the entries, 2 bar into 0 bar is 0 bar, 2 bar into 7 bar, 2 bar into 1 bar is 2 bar, 2 bar into 2 bar is 4 bar, 2 bar into 3 bar is 6 bar, 2 bar into 4 bar is what? Is 8 bar, and 8 bar is 1 bar in Z7. Then 2 bar into 5 bar is 10 bar. What is 10 in Z7? Is 3 bar. 2 bar into 6 bar is what? is 12 bar. And what is the value of Z7, 12 bar in Z7? If we divide 12 by 7, then 5 is the remainder. So 5 bar. Similarly, if we find these entries, 4 into 1 bar is 4 bar, 4 into 2 is 8 bar. And what is 8 bar? Is 1 bar. 4 into 3 is what? 12. And what is 12 bar? Is 5 bar, because if you divide 12 by 7, then 5 is the remainder. Similarly, 5 into, suppose 5 bar, 5 into 5 bar at this place. So it's 25 bar, and if we divide 25 by 7, then what is the remainder? Remainder is 4. That is 25. 7, 7 threes are 3 is the question. 21 and plus 4 means 4 is the remainder. 5 into 6 is what? 30 bar. If you divide 30 by 7, then what is the question? 4 is the question. That is 6 4s are 28 plus 2 is 30. So 5 into 6 bar, that is 30 bar, is 2 bar. Similarly, all the entries, 6, suppose 6 into 2, 6 into 4 bar is 24 bar, and 24 means 3 bar. That is, if you divide 24 by 7, then 3 is the remainder. All the entries. 6 into 6 bar is 36 bar. If you divide 36 by 7, then 7 5s are 35. That is, 1 is the remainder. So these are the tables for addition and multiplication in Z7. Similarly, draw the table for Z6, Z5, Z9, Z11, Z12. So next example, in Z12, calculate what? 2 bar into 9 bar plus 1 bar, and this. So first 2 bar into 9 bar plus 1 bar, inverse, right here, inverse. So first we'll find 2 bar into 9 bar is 18 bar. And what is 18 bar in Z12? If we divide 18 by 12, then 6 is the remainder. 1 is the question and 6 is the remainder. So actually this is 18 bar, but 18 bar is what? Is 6 bar plus 1 bar. And 6 plus 1 is 7 bar, and 7 bar inverse. Here is make correction, that find raised to minus 1. Raised to minus 1 means inverse. And what is 7 bar inverse? Is 7 bar. So how we can find its inverse? So in the next lecture we will see the inverse of the residue classes. So 7 bar inverse, as 7 bar into 7 bar is 49 bar, and if we divide 49 by 12, then 1 is the remainder. So 7 bar into 7 bar is 1 bar, and that's why 7 bar inverse is 7 bar. We'll see how we can find the inverse of the residue class in the next lecture. So minus 5 bar into 4 bar plus 5 bar. So first add these two. So 4 bar plus 5 bar is 9 bar. So minus 5 bar into 9 bar. And minus 5 bar is 7 bar. If we divide minus 5 bar, minus 5 by 12, then what is the question? 1 is the question and 7 is the remainder. Minus 5 plus 12 is 7. So minus 5 bar is 7 bar. So minus 7 bar is 7 bar. And then 7 bar into 9 bar is 3 bar. So if you divide minus 5 by 12, then quotient is 1. That is 12 ones are 12. Plus remainder is what? The quotient is minus 1. Because quotient may be negative, but remainder is always positive. So if you divide minus 5 by 12, then if you apply division algorithm, then what is the equation? Minus 5 is equal to 12 into minus 1 plus 7. So 7 is the remainder. So minus 5 bar is 7 bar. Actually, this is the additive inverse of this 5 bar. 7 bar is the additive inverse. And this, we will find this in the next lecture, that how we can find this minus 5 bar. It is 7 bar, and 7 bar into 9 bar is what? Is 63 bar. And if we divide 63 by 12, then 3 is the remainder. So 3 bar. So in this, express each of the following element of Z3, 0 bar, 1 bar, 2 bar. These are the element of Z3. That is, we have to find the value of 2 bar cube. So what is 2 bar cube? 2 bar into 2 bar into 2 bar. And by using the definition of multiplication, it is 2 into 2 into 2 bar. That is 8 bar. And what is 8 bar in Z3? What is 8 bar in Z3? If we divide 8 by 3, then 2 is the quotient and 2 is the remainder. So 8 bar is 2 bar. Okay. So then 100 bar. What is 100 bar? If we divide 100 by 3, then remainder is what? 1. 33 is the question. 333. 3 into 33 is 99 plus 1 is the remainder. So 100 bar is 1 bar. Minus 100 bar raised to 4. So first find minus 100 bar. So if we divide minus 100 by 3, then what is the question? Minus 34 is the question. Minus 100 bar, minus 100 is what? 3 into minus 34 plus 2. Don't write that minus 33 as the question. If you write 3 into minus 33, then it is minus 99. Then we have to write here minus 1. But remainder is always positive. We know the division algorithm theorem. Remainder is always greater than or equal to 0. It's positive or a 0. So if we divide minus 100 by 3, then minus 34 is the question and plus 2 is the remainder. And so minus 100 bar is what? Is 2 bar. And so minus 100 bar raised to 4 is what? Is 2 bar raised to 4. Similarly, here we divide this minus 5 by 12, then minus 1 is the quotient and 7 is the remainder. And that's why minus 5 bar is 7 bar. So remainder is always positive. Remainder is not negative. That is, don't write that 3 into minus 33 plus minus 1, because the remainder is always positive. So minus 34 is the question. If you divide 100 by 3, then 33 is the question and 1 is the remainder. But if you divide minus 100 by 3, then minus 34 is the question. Minus 33 is not the question. Okay? Because if you write here minus 33, then remainder is minus 1 and remainder is not negative. Is always positive, and therefore write minus 100 as 3 into minus 34 as the question and 2 is the remainder. And so minus 100 bar raised to 4 is what? 2 bar. Minus 100 bar is 2 bar raised to 4, means 2 bar into 2 bar into 2 bar into 2 bar 4 times, that is 16 bar. And what is 16 bar? 16 bar is 1 bar, because 3 5s are 15 plus 1 is the remainder. Okay. So minus 100 bar raised to 4 is what? Is 1 bar. And then 10 bar plus 1 bar is 10 plus 1 bar, that is 11 bar, and 11 bar is 2 bar. If you divide 11 by 3, then 3 is the quotient and 2 is the remainder. So 2 bar. So which of the element of Z6 satisfy x square is equal to x? So write for Z6, that is 0 bar, 1 bar, 2 bar, 3 bar, 4 bar, up to 5 bar. And then we have to find the elements whose square is itself. So first find 0 bar square is 0 into 0 is 0 bar. Then 1 bar square is what? 1 bar into 1 bar is 1 bar. Then 2 bar square is what? 2 bar into 2 bar is 4 bar. 3 bar square is what? 3 bar into 3 bar, that is 9 bar. And 9 bar is what? Is 3 bar. In a Z6, if you divide 9 by 6, then 3 is the remainder. Then what is 4 bar square? It's 4 bar into 4 bar, that is 16 bar. And 16 bar is what? If you divide 16 by 6, then 2 is the quotient and 4 is the remainder. So 4 bar. And then 5 bar square is what? 5 bar into 5 bar, that is 25 bar. And 25, if you divide 25 by 6, then 6 4 are 24 plus 1 is the remainder. So 1 bar. 5 bar square is 1 bar. 25 bar is 1 bar. And so what are the elements whose square are itself? 0 bar, because 0 bar square is 0 bar. 3 bar square is itself 3 bar. And 4 bar square itself 4 bar.